What does pressure do to you? It has no effect on the parts of you where there is no air. Unfortunately, that's most of you. But it does compress the air in your body air spaces. That's in your lungs, in your middle ear, and your sinuses. Pressure pushes gas atoms closer together. So this means the same number of atoms occupy a smaller space. Imagine taking a balloon on the water. As you go down and the pressure gets higher, the balloon will get smaller. It will still have the same number of gas atoms inside it, because the air cannot escape. The pressure will push the gas atoms into a smaller space. So the volume will be smaller, but the density, how close the atoms are together, will be larger. When you take the balloon back up again, the pressure gets less and the balloon gets bigger again. The volume will get larger and the density gets smaller. The gas atoms can move further away from each other.
So that means that if the pressure goes up, the volume gets smaller. And if the volume gets smaller, the density gets larger. And if the pressure goes down, the volume gets larger. And if the volume gets larger, the density gets smaller. Mr. Boyle discovered that these changes always happen in the same way. And this is why we call it Boyle's law. He found out that if you make the pressure 4 times higher, for example, the volume becomes 4 times smaller. And if the volume becomes 4 times smaller, the density becomes 4 times larger. Or another example, if you make the pressure 11 times higher, the volume becomes 11 times smaller and the density becomes 11 times larger. Or if you make the pressure 5.5 times higher, the volume becomes 5.5 times smaller and the density becomes 5.5 times larger. So what he discovered was that the pressure, volume, and density are in direct proportion to each other. We are going to use Boyle's law to calculate changes in volume.
ನಮಸ್ಕಾರ. ನನ್ನ ಹೆಸರು ತಾಂಡವಮೂರ್ತಿ ಎನ್, ವಿಜ್ಞಾನ ಸಹ ಶಿಕ್ಷಕರು, ಸರ್ಕಾರಿ ಪ್ರೌಢಶಾಲೆ ಕಾರ್ಮಂಗ್ಲ, ಬಂಗಾರಪೇಟೆ ತಾಲೂಕು. ನಾವು ಇವತ್ತು ತಾಪವು ಸ್ಥಿರವಾಗಿದ್ದಾಗ ಅನಿಲದ ಗಾತ್ರ ಮತ್ತು ಒತ್ತಡಗಳಿಗಿರುವ ಸಂಬಂಧವನ್ನು ಒಂದು ಸರಳ ಚಟುವಟಿಕೆ ಮೂಲಕ ತಿಳಿಯೋಣ. ಈ ಒಂದು ಚಟುವಟಿಕೆಗೆ ಬೇಕಾಗಿರ್ತಕ್ಕಂಥ ಸಮಯ ಸುಮಾರು 10 ನಿಮಿಷಗಳು ಸಾಕು. ಈ ಒಂದು ಸರಳ ಚಟುವಟಿಕೆಗೆ ಬೇಕಾಗಿರ್ತಕ್ಕಂಥ ಸಾಮಗ್ರಿಗಳು ಏನು ಅಂತ ನಾವೀಗ ನೋಡೋಣ. ಒಂದು 60 ml ಸಿರಿಂಜ್ ಬೇಕು, ಮತ್ತು ಅದಕ್ಕೆ ಏರ್ ಟೈಟ್ನರು ಮತ್ತು ಬಲೂನ್. ಇಷ್ಟು ಈ ಒಂದು ಚಟುವಟಿಕೆಗೆ ಬೇಕಾಗಿರ್ತಕ್ಕಂಥ ಸಾಮಗ್ರಿಗಳು. ಈ ಚಟುವಟಿಕೆ ಪ್ರಾತ್ಯಕ್ಷಿಕೆಯನ್ನು ನಾವೀಗ ನೋಡೋಣ. ಮೊದಲು ಪಿಸ್ಟನನ್ನು ಹೊರಗೆ ತೆಗೆದು ಆ ಬೇಬಿ ಬಲೂನ್ನ ಒಳಗಡೆ ಸೇರಿಸೋಣ. ಪಿಸ್ಟನನ್ನು ಸಿಲಿಂಡರ್ ಒಳಗಡೆ ತಗೊಳ್ಳೋಣ. ಮತ್ತು ಈಗ ಏರ್ ಟೈಟ್ ಮಾಡೋಣ. ಇಲ್ಲಿ ಒತ್ತಡವನ್ನು ಜಾಸ್ತಿ ಮಾಡ್ತಾ ಹೋಗ್ತಾರೆ ಇಲ್ಲಿ ಪಿಸ್ಟನ್ನ ಸಹಾಯದಿಂದ. ಅಲ್ಲಿ ಆಗ್ತಕ್ಕಂಥ ಬದಲಾವಣೆಗಳನ್ನು ಗಮನಿಸಿ. ಒತ್ತಡ ಜಾಸ್ತಿ ಆಗ್ತಾ ಇದೆ, ಆ ಬಲೂನ್ನ ಗಾತ್ರ ಏನಾಗ್ತಾ ಇದೆ ಗಮನಿಸಿ. ಮತ್ತು ಈಗ ಒತ್ತಡವನ್ನು ಕಡಿಮೆ ಮಾಡ್ತಾರೆ. ಪಿಸ್ಟನನ್ನು ಹಿಂದೆ ಕೇಳಿಕೊಂಡ್ರೆ ಒತ್ತಡ ಕಡಿಮೆ ಆಗ್ತಾ ಇದೆ, ಬಲೂನ್ನ ಗಾತ್ರದಲ್ಲಿ ಆಗ್ತಕ್ಕಂಥ ಬದಲಾವಣೆಯನ್ನು ಗಮನಿಸಿ. ಈ ಒಂದು ಸರಳ ಚಟುವಟಿಕೆಯಿಂದ ನಾವು ಏನನ್ನು ಗಮನಿಸಿದ್ವಿ ನೋಡೋಣ. ಇಲ್ಲಿ ಅನಿಲದ ರಾಶಿ ಸ್ಥಿರವಾಗಿತ್ತು, ತಾಪವು ಸ್ಥಿರವಾಗಿತ್ತು. ನಾವು ಪಿಸ್ಟನ್ನ ಸಹಾಯದಿಂದ ಒತ್ತಡವನ್ನು ಜಾಸ್ತಿ ಮಾಡ್ತಾ ಹೋದವು. ಒತ್ತಡವನ್ನು ಜಾಸ್ತಿ ಮಾಡಿದಾಗ ಗಾತ್ರವು ಕಡಿಮೆ ಆಗ್ತಾ ಹೋಯಿತು. ಈ ಒಂದು ಚಟುವಟಿಕೆಯಿಂದ ನಾವು ಬಾಯ್ಲ್ನ ನಿಯಮವನ್ನು ಭಾಳ ಅರ್ಥಗರ್ಭಿತವಾಗಿ ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಳಲಿಕ್ಕೆ ಸಾಧ್ಯವಾಗ್ತಾ ಇದೆ. ಬಾಯ್ಲ್ನ ನಿಯಮ ಏನು ಹೇಳ್ತದೆ? ತಾಪವು ಸ್ಥಿರವಾಗಿದ್ದಾಗ ಅನಿಲದ ಗಾತ್ರವು ಅದರ ಒತ್ತಡಕ್ಕೆ ವಿಲೋಮಾನುಪಾತದಲ್ಲಿರ್ತದೆ. ಇದು ಬಾಯ್ಲ್ನ ನಿಯಮದ ನಿರೂಪಣೆ. ಈ ಒಂದು ಬಾಯ್ಲ್ನ ನಿಯಮವನ್ನು ನಾವು ಈ ಒಂದು ಸರಳ ಚಟುವಟಿಕೆಯಿಂದ ತಿಳ್ಕೊಳ್ಳಲಿಕ್ಕೆ ಸಾಧ್ಯವಾಗ್ತದೆ.
You will perform an experiment illustrating Boyle's law. Boyle's law is the relationship between volume and pressure at constant temperature and constant number of moles. To collect data, we'll use a CBL, a calculator-based laboratory interface connected to a graphing calculator. The CBL is connected to a pressure probe, which in turn is connected to a syringe. The system is at constant temperature because it's at the temperature of the surrounding air. It's at constant number of moles because there's a fixed amount of gas trapped in the syringe. As we apply pressure to the handle on the syringe, we will decrease the volume of the gas. As we increase the pressure on the gas, the pressure will be read by a pressure sensor. The pressure sensor sends a voltage signal to the CBL. The CBL acts as an analog to digital converter which converts the voltage reading into a pressure reading. The pressure and the volume are graphed on the calculator.
The purpose of fluid power is to transmit power from one location to another. In the mid-1600s, Blaise Pascal, a French mathematician, made a very important contribution in the field of fluid motion. This contribution, known as Pascal's law, relates the transfer of pressure through a fluid. Pascal determined that a contained pressurized fluid will exert pressure equally in all directions. Pascal's law states that pressure set up in a confined body of fluid acts equally in all directions and always at right angles to the containing surfaces. Another important property of fluid mechanics was discovered in the late 1600s by Robert Boyle, an Irish physicist. Boyle's law is an experimental gas law which describes how the pressure of a gas increases as the volume of gas decreases. A modern statement of Boyle's law is the absolute pressure of a confined body of gas varies inversely as its volume, provided its temperature remains constant. In a physical system, this means that as the volume decreases, the pressure increases. Similarly, as the volume increases, the pressure decreases. Boyle's law can be expressed mathematically as the pressure at state 1 times the volume at state 1 is equal to the pressure at state 2 times the volume at state 2. This is true as long as both the temperature and mass, or amount of gas, remains constant. In the late 1700s, Jacques Charles, a French scientist and mathematician, discovered an important rule regarding gases under pressure. Charles's law, also known as the law of volumes, is an experimental gas law which describes how gases tend to expand when heated. It states that if the pressure of a gas is constant and its temperature is raised, the volume will also be raised by the same ratio. Additionally, the inverse is true. If the pressure of a gas is constant and the temperature is lowered, the volume will also lower. Charles's law can be expressed mathematically as the ratio of the temperature at state 1 to the volume at state 1 is equal to the ratio of the temperature at state 2 to the volume at state 2. This law is true as long as the pressure and mass remain constant. In the mid-1700s, Daniele Bernoulli discovered another very powerful rule in the field of fluid mechanics, known as Bernoulli's principle. This rule is related to the theory of conservation of energy, which states that energy can neither be created or destroyed. In this fluid system, pressure is potential energy and fluid flow is kinetic energy. Bernoulli's principle states that an increase in the speed of an incompressible fluid occurs simultaneously with a decrease in pressure. This is illustrated by the flow of water through a pipe. The volume of water flow through all three sections is the same. When the water's flow is restricted in section B, the speed of the water increases to maintain the same amount of volumetric flow. This increase of speed simultaneously causes a decrease in pressure. When the flow of water reaches section C, the inverse occurs. The water flow decreases and the pressure increases. This rule can also apply to the types of energy present in the system. As the pressure decreases in section B, the potential energy converts into kinetic energy. This increases the speed of water flow and decreases the pressure. When the water reaches section C, the kinetic energy is converted back to potential energy. This is illustrated by the decrease in speed of the water flow and its simultaneous increase in pressure.